Hello everyone, welcome to Mathworld. This video is to discuss Cambridge International A-Level Mathematics Paper 3, which is a pure mathematics 3 for October-November 2019, and the code is 9709/33. So let's move on to question number 1. For question number 1, solve the inequality of 2 modulus x plus 2 greater than modulus of 3x minus 1. So now first of all, I will rewrite the inequality. Okay, and then by using the definition of modulus, so modulus x is basically square root of x squared. Then from here, I will be getting 2 square root of x plus 2 greater than square root of 3x minus 1. Okay, so to solve this question, we need to square both sides. So when I square both sides, the 2 is basically brought into the whole bracket because of this formula. ab to the power of m equals to a to the power of m, b to the power of m. Okay, that means here I will be getting 2 squared. Then square root of x plus 2 squared and then squared. Greater than, this basically for the right hand side, the square and square root cancel off. So I will be getting a square of 3x minus 1. Okay, same goes to the left hand side here. The square and square root will be cancelled off. That means now for the left hand side is basically 2 squared, which is 4. Then x plus 2 squared greater than 3x minus 1 squared. And now here I will be expanding both sides with quadratic expansion formula. A plus b squared equals to a squared plus 2ab plus b squared. Then you will be getting 4 times x squared plus 4x plus 4 is greater than 9x squared minus 6x plus 1. Okay, so when I do expansion for the left hand side, you will be getting 4x squared plus 16x plus 16. That is greater than 9x squared minus 6x plus 1. So by moving all the terms on the left side to the right hand side, okay, so 9x squared minus 4x squared, you will be getting 5x squared. Minus 6x minus 16x minus 22x. And then 1 minus 16 is minus 15. So when we move all the terms to right side, basically it's less than 0. Okay, because we are reading from right to the left. Now, this quadratic function can be factorized into x minus 5 and then 5x plus 3. Then less than 0. Now, to get the final answer, we need to sketch this quadratic curve. Okay, so by looking at the coefficient of x squared is positive 5, that means the graph will have a minimum point. Alright, so now you let x minus 5 be 0, then your x is positive 5, and then when you let these brackets be 0, your x is negative 3 over 5. So now for final answer, it refers to this inequality, which is less than 0. So less than 0 means that it is below the x-axis, which means my region is going to be in between these two intersection points. So my final answer is basically between negative 3 over 5 and 5. This is my final answer. Okay, so done for this question, number 1. Question number 2. The polynomial 6x cubed plus ax squared plus bx minus 2, where a and b are constants, is denoted by px. So I will write down px first. Just copy back all these terms. It's given that 2x plus 1 is a factor of px. Now according to the factor theorem, okay, factor theorem, so if x minus a is a factor of fx, then fa equals to 0. So where to get this fa? You just let this be 0. Then your x will be a. Okay, so that means now I let this be 0. 2x plus 1 be 0. Then my x equals to negative half. So on other words, p of negative half equals to 0 according to this factor theorem. Okay, so from here I will just replace first. So yeah, I replace the x by negative half and replace the whole px by 0. So 0 equals to 6 times negative half cubed plus a times negative half squared plus b times negative half, then minus 2. So from here you will be getting 0 equals to negative 3 over 4 plus 1 over 4a minus 1 over 2b minus 2. So then I will rearrange this and simplify it into 1 over 4a minus 1 over 2b equals to 11 over 4. This is my first equation. Now, the next key term is when px is divided by x plus 2, the remainder is negative 24. So the remainder has to be referred to the remainder theorem. So when fx is divided by x minus a, for example, okay, x minus a, the remainder is 2. That means, right, fa equals to 2. So this is the remainder theorem. So what I need to do is I let this be 0, and then my f of this x will be negative 24. Okay, so means that now x plus 2 equals to 0. So my x equals to negative 2. That means p of negative 2, it will be negative 24, because negative 24 is the remainder. Then from here, I will substitute this result into the px. So I will be getting negative 24 equals to 6 times negative 2 cubed plus a times negative 2 squared plus b times negative 2 minus 2. Then from here, you will get negative 24 equals to negative 48 plus 4a minus 2b minus 2, and hence 4a minus 2b equals to 26. This is my second equation. So now to find the a and b, okay, according to the question, find the values of a and b. So now just solve these two simultaneous equations. Okay, so from the first equation, I can just times the whole equation by 4 to eliminate the denominator. So times 4, okay, therefore, or probably I will just write first times 4. First equation times 4, I will get a minus 2b equals to 11. Then now you will notice that both equations, I mean equation 2 and 3, are having the same term, which is negative 2b. Okay, then from here, I will say that my second equation minus third equation to get the a. So for the left hand side, 4a minus a is 3a. The 2b will be cancelled off. And then for the right hand side, 26 minus 11 is 15. Hence my a is 15 over 3. That is 5. So now to get the b, probably I will just refer to the third equation. So my a will be 11 plus 2b. Oh, sorry, you need to find the b now. Okay, so I need to get 2b equals to a minus 11. Right, so the 2b move to right side, the 11 move to the left side. So then from here, just replace. It will be 5 minus 11. Then my 2b is minus 6. Hence my b is minus 3. Okay, so done for the a and b. Okay, for question number 3, show all necessary working. Solve the equation. Give your answer correct to 3 decimal places. So 3 power 2x plus 3 power negative x over 3 power 2x minus 3 power negative x equals to 4. So first of all, I will just times, or I will just move the denominator to the right side. Then you will be getting 3 power 2x plus 3 power minus x equals to 4 times 3 power 2x minus 3 power negative x. Then now here I will just do expansion. This is going to be 4 times 3 power 2x minus 4 times 3 power negative x. Okay, so then from here, I notice that this is 3 power 2x, here also 3 power 2x, but the coefficient here is 1. This is 4. So it means I will move all the terms to the right side, because on the right side, the term has greater coefficient. Therefore, when I move, I will get 4 times 3 power 2x minus 4 times 3 power negative x. So the terms on the left side will be moved to the right side. It will become negative for both. Then equals to 0. Okay, so when you combine the first and third term, so basically the coefficients for both terms will be 4 and 1, 4 and minus 1. So 4 minus 1 is basically 3. I will write 3 of 3 power 2x. And then for the second and third and fourth term, both with negative sign. One is negative 4, another one is minus 1. Therefore, it will be minus 5 of 3 power negative x. Now, to solve this equation, because I have 3 power negative x there, so to eliminate the 3 power negative x, I need to multiply with 3 power x. That means now 3 times, okay, I have a formula here, a power b times a power c. That will be a to the power of b plus c. Okay, because here, when you times with this times this, basically the same base. So you are adding the degrees. It becomes 3x. So minus 5. When you times 3 power x to 3 power negative x and you add the degrees, it basically 0. 3 power 0 is 1. Okay, and now you need to get 3 decimal places. So what to do is just write 3 times 3 power 3x equals to 5 first. Then the 3 move down. So here I will get 3 power 3x equals to 5 over 3. And then now you can just take ln both sides. Ln 3 power 3x equals to ln of 5 over 3. And then we have a formula. Ln a power b is b ln a. So the 3 power x is the power. Okay, 3x, sorry. This 3x is the power of 3. So it means that it can be brought down according to this formula. So I will bring down 3x, then multiply with ln 3. Then this is going to be ln of 5 over 3. And now 3x equals to the division. Ln of 5 over 3 divided by ln 3. Then my x, okay, my x can be brought down as well. So, sorry, my 3 can be brought down as well. Okay, therefore here my x is going to be 0.155. So that is the solution of this question number 3. Okay, so for question number 4, first part, by first expanding tangent 2x plus x, show that the equation tangent 3x, that's why you are given the hint. The 3x you change to 2x plus x, then can be written in the form of this equation. So now I will start with tangent 3x equals to 3 cot tangent x. So the tangent 3x I change to tangent 2x plus x. This 3 cot tangent is 3 times 1 over tangent x. Okay, now use the formula tangent a plus b. This is tangent a plus tangent b over 1 minus tangent a tangent b. So it means that I will be getting tangent 2x plus tangent x over 1 minus tangent 2x tangent x. Then equals to 3 over tangent x. And now I need to get this quadratic equation whereby the degree for tangent x is 4. So the easiest way is just multiply first. Okay, then here I will be getting tangent x times tangent to x plus tangent square x. So for the other side, it will be 3. 3 times 1 is 3, then minus 3 tangent to x, tangent x. Okay, so from here, basically, if you are aware about that, okay, so from here, these two terms are equal, but with different coefficients, means that now this term I can move to the left side and combine together. So that will be 4 times of the term. So it will be 4 tangent x, tangent to x, then plus tangent square x. The 3 move to the left side becomes minus 3 equals to 0. Okay, then here, because you are given the equation in terms of tangent square x and tangent power 4x, therefore now, for the tangent 2x itself, I have to use the double angle formula. Tangent 2a is basically 2 tangent a over 1 minus tangent square a. That means now here I will be getting 4 tangent x, then 2 tangent x over 1 minus tangent square x. Okay, then from here I can just times the whole equation by 1 minus tangent square x. So for the first term, you just do expansion. That means just a numerator, you times together, and then for the second and third term, basically you are multiplying with 1 minus tangent square x. So here I will be getting 8 tangent square x plus tangent square x minus 3 multiplied with 1 minus tangent square x. And just do expansion. So 8 tangent square x plus, okay, so here tangent square x multiplied with the bracket, then followed by minus 3 multiplied to the bracket. So you will be getting plus tangent square x. So tangent square times negative tangent square is negative tangent degree 4. Then minus 3 times 1 minus 3. Minus 3 times minus tangent square is plus 3 tangent square x equals to 0. Okay, look at the question here. You need to get tangent degree 4x as a first term. So here I rearrange first, right? So then from here, this is negative tangent degree 4 x, and then followed by 8 tangent squared plus 3 tangent squared, means that plus 11 tangent squared, then plus one more tangent squared, that is plus 12 tangent squared x, and then minus 3 equals to 0. And now to get the equation, look at here, the coefficients are 1, minus 12, and 3. So means that I just times negative 1 to the whole equation, then you will be getting tangent degree 4x minus 12 tangent square x, then plus 3 equals to 0. So I have shown the given form. Okay, part 2, hence solve the equation. So exactly the same equation, hence means use the previous answer, means this quadratic equation. So I will rewrite tangent degree 4x minus 12 tangent square x plus 3 equals to 0, and then the x is in first quadrant. Now for this case, okay, I will change to u, that is u equals to tangent square x. Then my quadratic equation will be u squared minus 12u plus 3 equals to 0. And this quadratic equation cannot be factorized. Therefore, I have to refer to the quadratic formula, which is ax squared plus bx plus c equals to 0. This is a quadratic equation. The formula is minus b plus minus square root of b squared minus 4ac over 2a. Which means now, when you list down the coefficients, my a is 1, my b is minus 12, and then my c is 3. So now my u equals to minus b plus minus square root of b squared minus 4 ac is 4 times 3 over 2a. That means now here you will be getting 0.25544 when you calculate using minus, and the other value is 11.74456. And now I am solving u, but then the question is x. So now you change back. That means tangent square x is 0.25544, or tangent square x is 11.74456. And now since we need to find the x, that means we need to get tangent x instead of tangent square x. So now I have to take plus minus square root of each value. Then here you will be getting plus minus 0.50541. And the other tangent x is going to be plus minus square root of 11.74456, and you will be getting plus minus 3.4270. But then you don't forget that you are given the x in first quadrant. Okay, so given the x between 0 and 90 degrees, so it's known that the tangent value will be positive in the first quadrant. Alright, therefore your tangent x will be both positive. Okay, therefore now your x, you just use your calculator, inverse tangent of 0.50541, that is 26.8 degrees. And for the other one, inverse tangent 3.4270, that is going to be 73.7 degrees. So that's all for this question. For question number 5, first part, by sketching a suitable pair of graphs, show that the equation ln of x plus 2 equals to 4 exponential minus x has exactly one real root. So when exactly one real root means that both graphs having exactly one intersection point. That's why you need to sketch both graphs. So ln of x plus 2 equals to equals to 4e minus x. So I will let y1 be ln of x plus 2. My y2 is 4e minus x. Okay, so for the long graph, just a reference, this is a long graph. Right. Your x must be greater than 0. Okay, that means now here I will say my x plus 2 must be greater than 0. Therefore, my x must be greater than 2. Oh, sorry, greater than minus 2. That means, okay, or yeah, greater than minus 2. Okay, and from here, you see here, I notice that one more. Ln 1 equals to 0. So I let the x be 1, my whole value will be 0. So another thing is you can say x plus 2 equals to 1. Okay, when y equals to 0, x plus 2 equals to 1. That means x equals to minus 1. So I get 2 points, right? Which means I'm getting this graph now. So here, when minus 1, I get 0. It is greater than minus 2. So it means that this is my graph. So this is my y equals to ln of x plus 2. So you can just find out when x equals to 0, this is ln 2. Okay, done for the first graph. Now for the second graph, the exponential. So for exponential graph, when y equals to ex, this is our graph. It cuts at 1 at the y-axis. But e minus x means 1 over, okay? E minus x means 1 over ex, which means at the same point, 1 over 1 is still 1, but then here increase until infinity. So 1 over infinity will tend to 0. That means close to 0. And this part, 1 over infinity, 1 over 0 tends to infinity. So my graph will be this. This is my e negative x graph. Okay, and then look at here, this is 4. That means instead of 1, now becomes 4. So probably I will just say the other graph is, okay, I check what is my ln 2 first. My ln 2 is basically 0.69. Okay, so now which means probably 4 is over here. So I have to check this graph. Right? So probably this is 4. This is ln 2. Then this is my y equals to e minus x. So it will tend to infinity over here. So this one will tend to 0. Now from here you can just say there's only one intersection point. Therefore the equation has only one real root. There is only one intersection point. Hence, there is only one real root, or one real root, yes. Okay, so this is the explanation. Right, now part 2. Show by calculation that this root lies between x equals to 1 and x equals to 1.5. So I will rewrite this equation and move this for exponential negative x to the left side. So I will write ln x plus 2 minus 4e negative x equals to 0. So let fx equals to the left hand side and apply the sign change rule. So sign change rule, you need to calculate f1 and f1.5. So f1 means you replace x by 1 to get ln 3 minus 4e power negative 1. That is going to be negative 0.373, which is less than 0. And when the x equals to 1.5, you are getting ln of 3.5 minus 4e negative 1.5. And this is 0.360, which is greater than 0. So then you can just say, since f1 less than 0 and f1.5 is greater than 0, there is a sign change. Hence, the root lies between x equals to 1 and x equals to 1.5. Okay, so done for the second part. Now part 3, use the iteration formula. Formula is given, so let me rewrite first. Determine the roots equal to 2 decimal places. Give the answer of each iteration to 4 decimal places. Okay, so now here we need to know the initial x. So since we know that it's between 1 and 1.5, so you can just let x be any other numbers and let it be the middle value, which is 1.25. So let x0 equals to 1.25. Then your x1 will be ln of 4 over ln 1.25 plus 2. And this is going to be 1.2219, 4 decimal places. Now, if you need to get the answer correct to 2 decimal places, make sure you are getting 2 same digits. Okay, so obviously they are not the same because 1.25 changes to 1.22. So now I need to calculate y, x2. It will be ln of 4 over ln 1.2219 plus 2. So this is going to be 1.2293. So I notice that they are the same 2 digits now. Then final answer refer to the last value, the next value, since this is 9 and we have to round up. Okay, so therefore your x approximate to 1.23. So that is the solution. For question number 6, throughout this question, the use of calculator is not permitted. The complex number with modulus 1 and argument 1 over 3 pi is denoted by W. First part, express W in the form x plus iy, where x and y are real and exact. Okay, so basically, your W is R. Probably I will just write down first. R is 1. The theta is pi over 3. Okay, so your W is R cos theta plus I sine theta. Then from here, I will just write 1 cos pi over 3 plus I sine pi over 3. So cos pi over 3 is half. I sine pi over 3 is square root 3 over 2i. So that is your complex number W. The complex number 1 plus 2i is denoted by U. The complex number V is such that modulus V equals to 2 modulus U, and argument V equals to argument U plus 1 over 3 pi. Okay, sketch an Argand diagram showing the points representing U and V. Okay, so now here, my U is 1 plus 2i. This means the real part is 1, imaginary part is 2. So here, okay, so 1 plus 2i is here. This is the U. This is the O, origin. Now we need to get the V. Okay, the V, look at here. The magnitude of V is double of the U. And then the argument means that the angle from the positive x-axis, right here, is argument U plus 1 over 3 pi. So what to do is, this is the argument U. I need to add 1 over 3 pi. So 1 over 3 pi, that means it is 60 degrees, right? You just add another 60 degrees. That means probably it's like this. Okay, here is pi over 3. And then the length is double of the length of the U. Okay, so double probably is up to here. So this is your V, complex number. Right, so done for this part. Now part 3, explain why V can be expressed as 2UW. This is the first part. Hence, find V. Giving your answer in the form A plus IB, where A and B are real and exact. Okay, so from here we know that magnitude of V is 2 of magnitude U. Okay, magnitude of W is 1 in the previous part. So therefore, magnitude of V equals to 2 magnitude of U times magnitude of W. Okay, and then at the same time, your argument V equals to argument U from the previous part, right? Argument U plus 1 over 3 pi. So here, plus pi over 3. So then from the previous parts, look at here. We have, you are given, argument of W is pi over 3. So then from here, you will just write from first part. Okay, or, okay, given, no need to write, given argument W equals to pi over 3. That means here I can change. This is basically argument U plus argument W. Okay, so then from here, now because we need to prove 2UW, if you just write like that, this is just U, and U times W is not enough. So I will just add on one more, plus argument 2. So argument 2 is 0. Because when you draw the Argand diagram, this is 2. So the angle here is basically 0. Right? So then from here, I will just write this is basically V equals to 2UW. Okay, so this is how we explain it. Now, hence 5V. So how to find the V? V is 2U times W. U is basically given. So your U is 1 plus 2I. Then the W is found in the previous part. Half plus root 3 over 2I. Okay, so then from here, I will just do expansion. But before I do expansion, I notice that this half, this over 2 and over 2, both denominators can be simplified with the 2. So I will just direct cancel off first before I do expansion. So it becomes 1 plus 2i multiplied with 1 plus square root 3i. Okay, so what to do here is you just do expansion 1 times the whole bracket, then 2i times the whole bracket. So then I will be getting 1 plus square root 3i. Then 2i times 1 is 2i. 2i times square root 3i, it will be plus 2 square root 3i squared. So then, remember, I squared is minus 1. Okay, this is minus 1. Then I will be getting 1 minus 2 square root 3, and then plus square root 3 plus 2i. So this is my V. Okay, so for question number 7, the plane M has equation x plus 4y minus 8z equals to 2. The plane M is parallel to M, alright, and passes through the point P with coordinates. So the plane M passes through this point. Find the equation of N and giving the answer in this Cartesian form. So basically, this is your M and this is your N. Okay, two planes. So for the M, the N, right, the normal vector is 1, 4, minus 8. Just take the coefficient for the x, y, and z. So now, basically, when you look at this diagram, both N will be the same. Right? I will say this is N. So then from here, I will write N equals to 1, 4, minus 8. And then now to get the equation of the plane N, so I will use R dot N equals to A dot N. This is the vector equation. But then to get the Cartesian form, change the R into X, Y, Z. Then the N will be 1, 4, minus 8. And then the A is the point on the plane. 5, 2, minus 2. Dots with 1, 4, minus 8. Then from here, the left-hand side dot product we need to multiply and plus all together, okay, for both sides. So then I will be getting x plus 4y minus 8z equals to 5 times 1 plus 2 times 4 plus minus 2 times minus 8. Then right-hand side, you will be getting 29. So therefore, the plane N with this equation. Okay, now part 2, calculate the perpendicular distance from between M and N. Right, so I need to find out what is this distance. Perpendicular distance means that it is 90 degrees. Okay, because they are perpendicular, they are parallel to each other. Definitely it will be perpendicular distance. So here the distance can just write the perpendicular distance between planes M and N, that is going to be modulus of R dot M minus R dot N. Okay, so here R dot M is basically, okay, you can say NM, right? So I'll write NM, and then the other one is MN. Sorry, is N. Okay, so for your information, for the plane M, okay, plane M, R dot N equals to 2, 1, 4 minus 8. Right, so this 2 is basically the A dot N. Right, this is your R dot NM. This is your R dot NM. That is the formula equals to A dot N and M. So in order to get the hat, that is a units vector, which means I will just take 2 over, now you see the hat is basically the vector divided by its magnitude. So now I divide by the magnitude of the N, NM, which is square root of 1 square plus 4 square plus minus 8 squared. Okay, minus the other plane, so 29 over the magnitude of the vector. Okay, then from here, basically, you will be getting 2 over 9 minus 29 over 9. That is modulus of 27, modulus of negative 27 over 9. So at last, the perpendicular distance is positive 3 units. Okay, now for question 3, the line L lies in the plane N, passing through points P and perpendicular to OP, where the O is origin. Find the vector equation for the line L. Okay, let's say this is the plane N. Okay, and then passes through point P. Okay, let's say this is the line L, passes through points P and is perpendicular to OP. Right, so from here I know that the line must have direction vector B, and then this direction vector B will be perpendicular to the NN. So now I need to find out what is my B. Okay, so since the P is on the line, right, I would say that, wait, and okay, the L is perpendicular to, the L lies in the plane passes through P and is perpendicular to OP. That means the O is somewhere here. So OP. Okay, that means from here, firstly, I will let my direction vector of the line L be B. Direction vector of L be B equals to A, B, C. Because now I need to find out what is my vector B. Then from here, I know that B is perpendicular to N. So when perpendicular means that the dot product equals to 0. Then now, I will write ABC multiplied with 1, 4 minus 8 equals to 0. Therefore, A plus 4B minus 8c equals to 0. This is my first equation. At the same time, the B is also perpendicular to OP. So B dot OP equals to 0. Okay, and then the P is given in the previous question. Right, so 5, 2 minus 2. That means now here I will write ABC dot 5, 2 minus 2 equals to 0. Then my second equation is going to be 5a plus 2b minus 2c equals to 0. That's my second equation. So to solve this, since I have 2c, negative 2c and minus 4, I have 2b and 4b here. So probably the second equation I just times 2. So because I need to eliminate from second equation, or probably I just write second equation I times 2. So I will get 10a plus 4b minus 4c equals to 0. That's my third equation. So to solve first and third equation, since the 4b are the same, therefore I will use third minus first equation. 10a minus a is 9a. Minus 4c minus 8c. So it will be minus 4 plus 8. That is plus 4c equals to 0. Then from here, I will say that my a is basically minus 4 over 9c. Okay, then obviously you have two equations but with three unknowns. Therefore, you will be getting infinite solution. So which means I need to introduce the c. Okay, I introduce a parameter for the c. So let c equals to t. That means my a is negative 4 over 9t. Then to get the b, I will just substitute into first equation. So I will get minus 4 over 9, or probably I direct find the, okay, I direct just replace directly. So minus 4 over 9t plus 4b minus 8t equals to 0. Then from here, my b, I need to find b here. Okay, so I will be getting 4b equals to both negative terms move to the other side becomes positive. So it will be 76 over 90. Okay, then now your b just divide by 4. So 1 over 4 times 76 over 90, that is going to be 76 over 36t, and this is simplified into 19 over 90. So I found my b. So then from here, I know that my ABC is going to be, my A is negative 4 over 9t. Then my B is 19 over 9t. And then my C is t. So from here, I will factorize the t. Or I will factorize the over 9 as well. Because I have the fraction. So you factorize 1 over 9t. Then you will get minus 4, 19, and 9. Then I will say that my B is basically parallel to negative 4, 19, and 9. Okay, and now it's given that the line passes through points P. So then the line equation, vector equation of the line L, R equals to OT plus TB. So my OP is basically 5, 2 minus 2 is given in the question, plus T of minus 14, 19, and 9. So that's all for the working of this question. Okay, question number 8. The diagram shows the graph of y equals to secant x for x between 0 and half pi. Use a trapezium rule with two intervals to estimate the value, giving your answer correct to 2 decimal places. Okay, so if two intervals, so start from 0 until half pi. That means it will have 3 ordinates. I need to find out what is the middle value. So obviously the middle value, not half pi, it's until 1.2. So obviously the middle value is 0.6. So this is your x0, x1, and x2. Okay, so the h is basically 1.2 minus 0 divided by 2 intervals, therefore 0.6. Now, the trapezium rule says from 0 to 1.2 second x dx, it will be h over 2 first y plus last y, then the rest you times 2. This is the formula for trapezium rule. And then now here, just replace the values accordingly. So the y naught happens when the x is replaced by x naught, which is 0. So I will get second 0 plus second 1.2 plus 2 second 0.6. Okay, so we know that second x is 1 over cos x. So replace or change it to this form first. 0.6 divided by 2 is 0.3. So this is 1 over cos 0 plus 1 over cos 1.2 plus 2 times 1 over cos 0.6. And now calculate all this in radians. Okay, in radians mode. Right? Therefore, you will be getting 0.3. This is 1 plus 2.75 970 plus 2.42326, and then you will be getting 1.85. So that's the solution. Now part 2, explain with reference to the diagram whether trapezium rule gives an overestimate or an underestimate for the true value in the integral. Okay, basically from here, if you just draw two intervals, that means it will be roughly here, right? And wait, you need to integrate from 0 to 1 over 1.2. So half pi is basically 1.57. Okay, this is 1.57. So probably 1.2 is here. Alright? So then when you take two intervals, that means this is 0.6. So when you draw the trapezium, right? So trapezium means you need to connect these 2 points. So obviously your trapezium area of trapezium, right? Okay, here these are the two trapeziums. The area of trapezium is basically greater than the area under the curve because the integration is the area under the curve. So obviously the trapezium rule is an overestimate. Okay, so just explain overestimate. Right, as shown in the graph. Okay, so that's all for the answer. Now part 3, point is P is a point on a curve y equals to second x, where x is between 0 and half pi, at which the gradient is 2. So whenever you see gradients, that means dy dx, right? Dy dx by first differentiating 1 over cos x. So instead of second, you change to 1 over cos. Find the x coordinate of P, giving your answer correct to 3 decimal places. So from here, I will say y equals to second x, which is 1 over cos x. This is same as cos x power negative 1. So we need to find the dy dx gradient first and let it be 2. So now the dy dx, when you differentiate, you need to refer to the products rule, the power rule. So differentiate fx degree n, that is n fx degree n minus 1, then fx becomes f prime x. So here becomes minus 1 cos x degree minus 2. When you differentiate cos x, that is negative sin x. Then here is going to be, okay, minus minus is positive, so I get sin x over cos square x. And now it's given gradient is 2. So given dy dx is 2. That means 2 equals to sine x over cos square x. So I will just move up the cos square x to the left side. Then you will be getting this equation. And now to solve for the x, we need to apply the identity. Sine square a plus cos square a equals to 1. So which means cos square a is 1 minus sine square a. Then I will be getting 2 of 1 minus sine square a x equals to sine x. And now you do expansion. So for the left hand side, you will get 2 minus 2 sine square x, then equals to sine x. Okay, and now here, the left hand side, all the terms will be moved to the other side. So it means that I will be getting 2 sine square x plus sine x minus 2 equals to 0. Okay, this is a quadratic equation. So, but then in terms of sine x, now I will solve this quadratic equation using formula. That is x squared so minus b plus minus square root of b squared minus 4ac over 2a. So my a will be 2, b is 1, c is minus 2, all the coefficients. So instead of x, I will change to sine x. It will be minus 1 plus minus square root of b squared minus 4ac over 2a. Then from here, you will be getting 0.7808 for the first value, and the next value is negative 1.2808. Okay, now here I get 2 sine x, but then the question asking for x of coordinates for the p. Okay, only one x. That means now it is restricted to this interval. So the x is defined for 0 to half pi. So from here, when x is defined from 0 to half pi, we know that this means the angle is in first quadrant. Therefore, the sine x must be positive. Okay, so on other words, I will get sine x equals to 0.7808. So with this sine x value, I can find my x by taking inverse sine. So my x is inverse sine 0.7808. That is going to be 896. So my x coordinate of p equals to 0.896. So that's the solution of this question. Question number 9. The variables x and t satisfy the differential equation. Given x equals to 10 when t equals to 0. First part, using partial fractions, solve the differential equation, obtaining an expression for x in terms of t. So I will rewrite the question first. Alright, so using partial fractions, firstly we need to split the variables. So since the dx is the numerator, all the x will be on the left side. Then I will be getting 1 over 20 minus x times 40 minus x dx equals to 1 over 5 dt, and integrate both sides. Okay, so for the left hand side, we need to solve using partial fractions. That's why you are given the hint in the question, using partial fractions. Right, so from here, I will just write let 1 over 20 minus x times 40 minus x equals to a over 20 minus x, because you are given the proper rational function, plus b over 40 minus x. Okay, then from here, to get the same denominator, so I will times the first rational function by 40 minus x and divided by the same term. For the second rational function, you multiply with 20 minus x, then over 20 minus x. So now since now I'm getting same denominators, therefore we can just ignore the denominators and consider the numerators. So 1 equals to a times 40 minus x plus b times 20 minus x. So to get the a and b, I will just use the substitution method, means that I will let the factor be 0. So when I let 40 minus x be 0, that means my x equals to 40. So 1 equals to, whenever you see 40 minus x, that will be 0. So which means I will be getting b times 20 minus 40, that is negative 20. Then you will be getting b is negative 1 over 20. So then the next one is I let 20 minus x be 0. That means my x is 20. So 1 equals to a times 40 minus 20, that is 20. Therefore, the b is 1 over 20. Okay, so after I found this, I will just substitute back into this left-hand side. Okay, I mean these partial fractions. So it will be 20 minus x, 1 over 20 minus x times 40 minus x. Okay, wait, mistake, this is a, not b. Since both also fraction, I will just factorize the fraction. Then here will be 1 over 20 minus x. Then minus 1 over 40 minus x, because both are same values, and one is positive, one is negative. Now I substitute back into this general question, right? So I take integration both sides. So 1 over 20 integrate of these two terms equals to 1 over 5 integrate dt. So now for the first part, to integrate fx dx, to integrate over fx with respect to x, make sure the numerator is f prime x, then this will be ln of fx plus c. So then from here, I can split it into two integrations. Okay, so probably here I split. So that means this is dx, then I minus another integration and times by 1 over 20. So I will write 1 over 20, I integrate 20 minus x dx. When I differentiate 20 minus x is basically minus 1. So I times another minus outside to make it to positive. Same goes to the next integration. So when I differentiate 40 minus x, it is minus 1. But then here initially positive 1. Okay, look at here. This one initially positive 1. I have obtained minus. Therefore, I times another minus outside. So right side remains. Okay, then from here, I will be getting 1 over 20. Then the first integration is negative ln 20 minus x. I put a modular sign here to make sure that it is positive. Right, then minus minus, refer to here, minus minus is a plus. So the whole integration is ln of 40 minus x. If you are sure that the value, the 40 minus x will be always positive, then no need to put a modular sign. So just to be safe, I put modulus. Now by right, when you integrate both sides, you have to add the constants both sides. But then my left side, probably I let y plus c, then right side I plus d. So the c and d I simplify becomes k, or another c on the right side. Okay, both are accepted. So now to get the c, I need to replace the values. X is 10, t is 0. So when t is 0, x is 10, then I will get 1 over 20 times negative ln, replace the x by 10, so 20 minus 10 is 10, plus ln 40 minus 10, I get 30, and then the t is replaced by 0. Therefore right side only have c. Then now my c is 1 over 20 ln 30 minus ln 10. We have an identity. Ln a minus ln b is ln a over b. Therefore this is ln 30 over 10. Then I will be getting 1 over 20 ln 3. Okay, so now my final answer, look at the question first. You need to get x in terms of t. So now I need to substitute back into this expression. So I will get 1 over 20. Okay, so since there are two ln here, I will just divide first. So it will be ln of 40 minus x over 20 minus x, because of minus of 2 ln, that equals to 1 over 5t plus 1 over 20 ln 3. And now I will times the whole equation by 20. So therefore ln of 40 minus x divided by 20 minus x, that is 1 over 5 times 20 is 4. Okay, then you will get 4t plus ln 3. And now the question says you need to get the x as a subject. Okay, x in terms of t. So now I need to eliminate the ln. So what to do is, you can just take e both sides, okay, or you can just move down the ln 3 first. We have two options. So if I move down the ln 3, that means it's minus, right? So it's like ln 40. Or if I don't want to move down, I will just take e both sides. So I better take e both sides. So e, but there's only restricted to one e on both sides. Okay, for the right side, you have two terms, e to the power of a plus b, that is ea times eb. Okay, then from here, the e and ln on the left hand side, e and ln fx is basically fx. So it means that for the left hand side, I will get 40 minus x over 20 minus x. Then for the right side, I will write e40 times e ln 3. So the e ln 3 will be 3, according to the e ln x equals e ln fx equals to fx. So from here, I will get 3e40. Now, again, to get the x as a subject, I will just move the 20 minus x to the right side. Okay, so it means I times 20 minus x. Therefore, 40 minus x equals to 3e40 multiplied with 20 minus x. Then now here, when you do expansion, this is going to be 60e40 minus 3xe40. And to get the x, those terms with x must be grouped together. So which means I will move this minus 3xe40 to the left side, and 40 will be moved to right side. Okay, this is e. Okay, so I will be getting 3xe40 minus x, that equals to 60e40 minus 40. Then now here, to get the x as a subject, I will be getting 3e40 minus 1. Then for the right side, the 20 is in common, so factorize the 20. So I get 3e40 minus 2. So at last, my x is 20 times 3e40 minus 2 over 3e40 minus 1. So that is the solution of this question. Now state what happens to the value of t, to the value of x when t becomes large. So when t becomes large, okay, now your x equals to 20. Okay, I copy this first. 20, 3e40 minus 2 over 3e40 minus 1. So to solve this problem, I have to factorize the e40. Okay, so I will write 20e40. So when you factorize e40, from the numerator and denominator, I will be getting 3 minus 2e negative 4t. So for the denominator, when you factorize e 4t, you will be getting 3 minus e negative 4t. So now the e 4t will be cancelled off. Okay, so when t is large, becomes large, that means t tends to infinity. E negative 4t is basically 1 over e 4t. So we know that e 4t will tend to infinity, but then it is the denominator. So 1 over infinity, it tends to 0. Okay, therefore your x will tend to 23 minus 2 times 0 over 3 minus 0. So at last, you will be getting this x tends to 60. So 20 times 3 over 3. Therefore, your x tends to 20. Okay, so that's the solution of this question. For question number 10, the diagram shows the graph of y equals to exponential cos x sine cube x for x between 0 and pi. And its maximum point M. The shaded region R is bounded by the curve and the x-axis. First part, find the x-coordinate of M. So M means stationary point or maximum point, means that we need to differentiate. Show all necessary working and give your answer equal to 2 decimal places. So now my y is exponential cos x sine cube x. This is basically the products rule. Okay, so products rule, d over dx uv, that is uv prime plus vu prime. So I will write down first, my u is exponential cos x. Now u prime, differentiate exponential cos x, you copy back the whole exponential. Then you differentiate cos x, it will be minus sine x. Right, so your v is sine cube x. Sine cube x is basically cube of sine x. So your v prime, you bring down the 3. Rewrite the function, degree becomes 2, differentiate sine x becomes cos x. So basically this is 3 sine square x cos x. That is your v prime. So now my dy dx is basically products rule. So it will be e cos x 3 sine square x. Okay, probably I write like this. Then plus sine cube x minus sine x exponential cos x. Okay, that is my dy dx. And now here you need to get the maximum point, which means dy dx equals to 0. Then from here, I know that the common term is the exponential. Okay, then I have, here I have sine squared. Here I can factorize sine squared. So which means the common term is exponential cos x sine square x. Then you will be getting 3 cos x. So the second term left minus sine degree 2x. Now, when d at m, I will say at m, dy over dx equals to 0. So exponential cos x cannot be 0 because exponential graph always above the x-axis. Sine square x cannot be 0 at m because when sine square x equals to 0, that means it will be 0 and then pi. So obviously, your m is not pi, right? Therefore, my 3 cos x minus sine square x must be 0. Then now to solve this, what to do is I change the sine square x into 1 minus cos square x because of this identity. So when you change, this is 1 minus cos square x equals to 0. And now here, I will be getting 3 cos x minus 1 plus cos square x equals to 0. It is a quadratic equation. And now I rearrange it. This will be cos square x plus 3 cos x minus 1 equals to 0. And this quadratic equation cannot be factorized. Therefore, we have to use a formula, quadratic formula, whereby the coefficient for cos square x is 1, b is 3, and c is minus 1. Use back the quadratic formula, then you will be getting cos x equals to minus b plus minus square root of b squared minus 4ac, okay, over 2a. And then here you will be getting negative 3.303 and 0.3028. But then we know that cos x will not be negative 3. Minimum is negative 1. So that means my cos x is 0.3028. Therefore, my x is going to be 1.26. Okay, because your x is between 0 and pi. That means it will be just first quadrant, right? Otherwise, your cos x will be a negative value. Okay, so that is your x value done for the x coordinate of m. Okay, now B, part 2. By first using the substitution u equals to cos x, give the exact value of the area of R. Okay, so now to solve this question, the area of R, look at the graph, it is defined from 0 to pi, and then we need to integrate. So your area equals to integrate from 0 to pi e cos x sine cube x. And then it's given u equals to cos x. So therefore, du over dx, differentiate cos, will be negative sine x. That means now here, okay, I notice that instead of cos cube x, the sine cube x dx, I can just combine. Alright, so give me 1 minute. So instead of sine cube x, we can change to sine x dx. Alright, then from here, you will be getting du negative du equals to sine x dx. Okay, so then I need to calculate my u values. So when x equals to 0, my u is cos 0, which is 1. When my x is pi, my u is cos pi, that is minus 1. Which means now here I will change 0 to pi first. I rewrite first, e cos x. Then the sine cube x change to sine square x, sine x dx. Then the sine square x I will change to identity. That is sine square x plus cos square x equals to 1. Which means my sine square x is 1 minus cos square x. Therefore, I will be getting 0 to pi exponential cos x, then 1 minus cos square x sine x dx. Okay, so now since all in terms of cos and also remain the sine x dx, so now I will change to u right now. So look at here, x0, your u is 1. When x is pi, your u is minus 1. Then eu, this is 1 minus u squared. Sin x dx, look at here. Sin x dx is minus du. So, minus du. Okay, then now here, before I integrate, I will have to solve this using the integration by parts. So the minus, I will bring it in. Alright, so I don't want to keep outside. So here will be EU bracket u squared minus 1 du. So for integration by parts, so integrate u v prime dx equals to uv minus integrate v u prime v du dx. Then limits a to b. So consider all the limits now. Then here you will be getting my u. Okay, instead of using u, because my integration in terms of u, I change my u in the formula into w. So let's w be my u in the formula, that is u squared minus 1. So my w prime is 2u, and then my v prime is eu. My v is eu, because you integrate eu, still eu. So now from here, I will be getting okay, wv, so u squared minus 1 times exponential u with limits 1 to minus 1, then minus integrate v u prime. So now becomes v w prime. Okay, so then I'm getting this now, which means you, for the first part, no problem, just replace. So u squared is minus 1 squared. Minus 1 squared, you minus 1 is still 0. So first term is 0. Then minus, when the u is replaced by 1, it's still 0. So everything is 0. So I need to integrate 1 to minus 1, 2u eu du. Again, this is by parts. Okay, so my w is 2u, and then my v prime is eu. So therefore my w prime is 2, my v is eu. So from here, again by parts, so then it will be negative of uv. So now becomes wu. So I will get 2u eu limits from 1 to minus 1 minus integrate v du. So v u prime, v w prime. So 2 eu du limits from 1 to minus 1. Okay, then from here, just replace. So I will get, replace u by negative 1 first. So minus 2e minus 1 minus, when the u is 1, so 2e1. Then again, when you integrate 2eu, it will be 2eu. Then from here, I will get minus minus is a plus, so 2e minus 1, again plus 2e, and then this minus and minus again plus 2. Okay, so I replace the u by minus 1, so e minus 1 minus e1. Then from here, when I open the brackets, I will get 2e power negative 1 plus 2e, and then this 2 multiplied to the bracket, so it will be plus 2e minus 1, and then minus 2e. Okay, there's no bracket. Right, then from here, you know that the 2e and minus 2e cancel off. At last, I will be getting 4e power negative 1. So this is the exact value. Okay, so I have completed the whole paper and also comes to the end of the video. Please subscribe to the channel and share this channel with your friends if you enjoy watching my videos. Thank you and bye.